So in this video, we're going to start with talking about empirical formulas from percent composition, and this is chapter 3 material. And to dive right in, I want you to write down the steps that I'm about to give you, okay? And it's your strategy for solving this type of problem. Okay, first, and this is the important one, assume a 100-gram sample. Okay, that allows you to convert your percentages to mass. Okay, easy. You don't have to do any multiplying or dividing or anything. If you assume that you have a 100-gram sample, your percentages simply become mass. Okay, so step 2, use the molar mass to convert to moles. Three, divide all of them by the smallest number of moles. Okay, and 4 is only if necessary. Multiply everything by a common factor. To get whole numbers. And I apologize if my handwriting starts to get a little bit tricky. I've done quite a few videos today, and it's a lot of writing. But I'm going to try and keep it together for you. Okay, so step 1, assume that you have a 100-gram sample to convert percent to mass. Step 2 is to use molar mass to convert each of them into moles. Step 3 is to divide all of them by the smallest number of moles. And if you don't have whole numbers for everything, you'll multiply by a common factor to get whole numbers. All right, so let's do an example. A sample has a composition that is 44.77% carbon, 7.52% hydrogen, and 47.71% oxygen. What is the empirical formula? Okay, so step 1, assume 100-gram sample. Right, so if I say that I have 100 grams and I'm 44.77% or per 100, then that's the same thing as dividing by 100. So that means that I have 44.77 grams of carbon, 7.52 grams of hydrogen, and 47.71 grams of oxygen. Easy. Okay, step 2, convert to moles. All right, so we use molar mass as conversion to convert everything to moles. So if I have 44.77 grams of carbon, and carbon is in 1 mole of carbon, 12.01 grams of carbon. Okay, remember that molar mass, that grams per mole, is a conversion factor. So if I start with grams, I can just put grams on bottom. No harm, no foul. My grams will cancel out, giving me 3.727 moles of carbon. do the same thing for the oxygen, 7.52 grams of, do the same thing for the hydrogen. And we are 1 mole of hydrogen, 1.008 grams of hydrogen. Grams will cancel, giving me 7.46 moles of hydrogen. And then we have 47.71 grams of oxygen. 1 mole of oxygen is worth 16 grams. And we get 2.982 moles of oxygen. All right, so I've got 3 moles of carbon, 7 moles of hydrogen, and 2 moles of oxygen. Okay, so I'm going to divide by the smallest moles, so that's step 3. Right, so if I have 727 moles of carbon divided by my smallest moles, which is the moles of oxygen, so divided by 2.982, that gives me a number of 1.25. My hydrogen, 7.46, divided by 2.982 gives me 2.50. And of course my 2.982 moles of oxygen divided by itself okay, so I don't have whole numbers. I have to have whole numbers. Okay, so I'm going to multiply everything by a common factor. That's our step 4. Okay, so I can, and I mentioned this in a class meeting recently, if you're not sure off the top of your head what that factor will be, just give it a try. Say, 1.25 times 2 times 3 times 4 times 5, however many it takes to get a whole number out of it. And then see if that same number works for everything else. In this case, I'm going to multiply everything by 4. Let me change colors here. Okay, and when I do that, that gives me 5 moles of carbon, 10 moles of hydrogen, and 4 moles of oxygen. Okay, so that is my empirical formula. Carbon with 5 moles, hydrogen with 10 moles, and oxygen with 4 moles. Okay, now, what happens if, say for example, I accidentally picked a multiplication factor of 8? Okay, that would have everything be 10, so I would have 10 carbons and 20 hydrogens and 8 oxygens, in which case I can divide that all by 2 and get the lowest possible number. Okay, remember that empirical formulas are the lowest values that maintain the proper ratio. I can't divide the 5, the 10, and the 4 all by the same factor and get a lower value in whole numbers. Okay, so that's how I know that my empirical formula is this. Okay, I'm going to go ahead and stop this video right here, and we'll continue on with the next video talking about combustion analysis.